Hello everyone, welcome back to 19th session of this IoT course. Last session I have discussed what is IoT security and why it is needed. Then I have discussed what is blockchain, why it is needed. Then I have implemented blockchain in Raspberry Pi and secure temperature and the humidity data by using blockchain. Today I will start with a very trending topic, that is AI enabled IoT. Mainly I will focus on how to use ML algorithms for IoT applications. Agenda of this session: I will start with introduction to ML, then I will discuss categories and techniques in ML, use cases, classification in action, AI enabled IoT architecture, AI enabled IoT system, introduction to Google Colab, and few challenges. Introduction to machine learning. So guys, you can see the picture from my presentation. There are many keywords: AI, machine learning, KDD, then databases, data mining, statistics, pattern recognition, neurocomputing. So guys, sometimes we are confused with the term machine learning, AI, deep learning, etc., etc. So basically the machine learning is a subset of AI and the deep learning is a subset of machine learning. So subfield of artificial intelligence, name is derived from the concept that it deals with construction and study of systems that can learn from data, can be seen as building blocks to make computers learn to behave more intelligently. It is a theoretical concept, therefore various techniques with various implementations. I will discuss all these techniques. What is machine learning? Machine learning is a type of artificial intelligence that provides computers with the ability to learn without being explicitly programmed. That means you have to teach the machine, by which machine will be intelligent enough to answer your question. How to recognize features? Can you tell me what do you mean by apple? Guys, you can see the pictures from my presentation. So what are the features? For red apple, features may be color, that is reddish or red, type may be fruit, maybe the shape will be the another feature. For the middle one, this is the apple logo. The color will be sky blue, the type will be logo, and the shape will be like this. And the third one, that is the yellow apple, the color should be yellow, type should be fruit, and the shape will be like this. This is called the feature. So how can I identify an object? That is basically the feature. That means the properties, or you can say the characteristics that help to identify any object. Some terminologies: features and labels. The number of distinct traits that can be used to describe each item in a quantitative manner. If y is a function of x, then x is called feature. Label is the output of the independent variables of a function, that means y. If y is a function of x, then y is called label and x is called feature. Training data. Generally, the entire data set that we have collected, right, for train the machine, generally divided into two parts. One is called the training data set, another is called the testing data set. The level data used to teach the machine to identify the levels based on features. That is basically the training data. That means this data set, this subset of data set, you can say, used to train the machine. Another one is the testing data set. The data set used to validate whether the machine learning algorithm is working correctly or not. Okay, that means after teach the machine, so you have to test the machine whether the machine is working properly or not, or machine learning algorithm is working properly or not. So then you need this testing data set for validate this thing. Now I'll come to workflow. You can see the first part is the training, the second part is the prediction, right? So in training, what you have to give? You have to give input and there must be a feature extractor algorithm that will extract the features from the input, like color, shape, type, etc. And correspondingly you have to give the output also, like red apple, like apple logo, like yellow apple, like this, to machine learning algorithm. And then that means after training, this machine learning algorithm is converted to a model. Okay, that means this model is now able to give some output depending on input. As you can see the prediction, so here you have to give the input, and once again the feature extractor algorithm will extract the features like shape, color, type, etc., etc., and it should be given to classifier model, that is the model we are talking about, and then model will give some output like red apple, like yellow apple, like apple logo, like this. Okay, so that is the workflow of any machine learning algorithm. There are different categories of machine learning: supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. What is supervised learning? Supervised learning is a learning in which we teach or train the machine using data which is already labeled. That means some data is already tagged with the correct answer. Already I told you this thing. After that, the machine is provided with a new set of examples and produces a correct outcome from labeled data. That means in supervised learning, you have to train the machine with proper data set, that is called the labeled data set, and after that this machine learning algorithm is converted to a model, machine learning model, and then this model can able to answer your question. That means you have to give some input and machine learning algorithm will give some output. It should be the correct output. For instance, suppose you are given a basket filled with different kinds of fruits. You teach the machine the different parameters of fruits like shape, color, smell, etc. Then you ask the machine to classify a fruit based on its parameter. Unsupervised learning. Type of learning where the machine does not have any prior knowledge about the parameters of the classes. It classifies the labels based on certain common features or patterns. For instance, suppose it is given an image consisting of both dogs and cats, which the machine has not seen ever. Thus, the machine has no idea about the features of dogs and cats. So, it cannot distinguish between them, but it can categorize them according to their similarities, patterns and differences. For example, a dog's ears are a bit lengthy than that of cats. That is called the unsupervised. That means there is no pre-trained model. Okay. So we can say, suppose we are purchasing some trouser from some online website. In that case, so the website, that is the shopping site, can recommend you to purchase the belt or t-shirt and etc. etc. That is once again a good example of unsupervised learning. So depending on the some common features or patterns, the system will recommend you that you purchase a belt or a shirt because you are purchasing trousers. That is, we can say, it's unsupervised learning. Semi-supervised learning, a mix of supervised and unsupervised learning, where some of the data is labeled and some of the data are not labeled. That means some of the data tagged with correct output or some of the data are not tagged with correct output. For instance, internet content classification. Labeling each web page is an impractical and unfeasible process and thus uses semi-supervised learning algorithms. Even the Google search algorithm uses a variant of semi-supervised learning to rank the relevance of a web page for a given query. Reinforcement learning. In this kind of learning, input depends on previous output. Machine will learn from the experience. Okay. Reinforced learning is all about making decisions sequentially. In simple words, we can say that the output depends on the state of the current input and the next input depends on the output of the previous input. Allows the machine or software agent to learn its behavior based on feedback from the environment. This behavior can be learned once and for all or keep on adapting as time goes by. For instance, when a computer plays a game of chess with a human, its game improves with time. This is an instance of reinforcement learning. So that is very common. So when we are playing a game, right? So depending on your previous output, the game will improve its performance. Learning techniques. There are different learning techniques. The first one is the classification, that actually predict class from observations, clustering, group observation into meaningful groups, regression, that is basically the prediction, predict value from observation. What is classification? Classify a document into a predefined category. It is a supervised algorithm. Let us say supervised learning algorithm. Documents can be text, images. Popular one is name based classifier. Steps. Step 1. Train the program, that is building a model, using a training set with a category, for example, sports, cricket, news, etc. Classifier will compute probability for each word, the probability that makes a document belong to each of considered categories. Step 2. Test with a test data set against this model. Very common classification problem. Sometimes in medical science we have to classify whether a tumor is malignant or benign. In such cases, advanced classification techniques are being used. A high resolution photo of the cells used as the input. The features are extracted and it is then classified as malignant or benign. This method is used in advanced medical precision detection system. Guys, you can see the pictures. The one is the benign tumor picture, another one is malignant tumor picture. So your model, the classifier model, can detect whether it is benign or whether it is malignant. That is basically the classification, very common classification problem. Now I will come to the clustering. Clustering is the task of grouping a set of objects in such a way that objects in the same group, called a cluster, are more similar to each other. It is an unsupervised learning algorithm. Objects are not predefined. For example, these keywords like men's shoe, women's shoe, then women's t-shirt, men's t-shirt can be clustered into two categories like shoe and t-shirt or men and women. Now I will tell you a very popular clustering algorithm is called the k-means algorithm. Partition n observation into k clusters in which each observation belongs to the cluster with the nearest mean, serving as a prototype of the cluster. What are the steps? Step 1, initialize k cluster centers. K must be known beforehand. Group all the points to one cluster based on Euclidean distances. The more close a point is to the cluster center, the more likely it belongs to the same cluster. Number 3, update the center by replacing with the current mean of all cluster points. Guys, you can see the pictures. So the one is the green cluster, you have the blue cluster, you have the red cluster, like this. Hierarchical clustering, method of cluster analysis which seeks to build a hierarchy of clusters. There can be two categories, or less we can say the strategies. Agglomerative approach. This is a bottom-up approach where each observation starts in its own cluster and pairs of clusters are merged as one moves up the hierarchy. The time complexity will be order of n to the power q, has a Euclidean threshold distance to correctly cluster observations. Another one is the divisive, but it has very high time complexity, that is exponential time complexity. This is a top-down approach. All observations start in one cluster and splits are performed recursively as one moves down the hierarchy. Now come to the regression. It is a measure of the relation between the mean value of one variable, that is output, and corresponding values of other variables. For example, time. It is a supervised learning algorithm. Guys, you can see the mean from the picture. There are many points, but the straight line is basically the mean. Regression analysis is a statistical process for estimating the relationship among variables. Regression means to predict the output value using training data. Popular one is logistic regression, sometimes called the binary regression, predicts the probability of one event where two events are mutually exhaustive. Point to be noted, in linear regression, line is drawn in such a way that the sum of the perpendicular distance from the line to all the observations is minimum. I am talking about the mean. This one, guys. This is the line, the straight line, the mean line. One regression problem. Let's say we have to predict house prices given some specific features of the house like plot size, number of bedrooms, etc. We can say intuitively, as the plot size increases, so does the price goes higher. So there is a linear, that means increasing relationship between the feature and the label. Thus, given enough training data, the house price can be predicted given a plot size. Guys, you can see, so here is the size, maybe in the square foot, or this is the price, maybe in the rupees or dollar, whatever. That means regression helps to predict some house price depending on the plot size, or you can say the number of bedrooms or the area, whatever you can say. Difference between classification and regression. Classification means to group the output into a class. Regression means predict the output value using training data. Classification to predict the type of tumor, for example, harmful or not harmful, using training data. Regression to predict the house price from training data. If it is discrete or categorical variable, then it is classification problem. If it is a real number or continuous, then it is regression problem. Let us see the uses in real life. Some use cases. The first one is machine translation. That means machine learning can be used to translate from a language to another language. Image search, the similarity or dissimilarity of images. Clustering, Amazon recommendations. So already I told you, when you want to buy something, so your system may recommend you to buy this one also. Classification, Google. Text summarization, Google News. Rating a review or comment. Yelp. Fraud detection, credit card providers. Decision making, for example, bank, insurance sector. Sentiment analysis, speech understanding, iPhone with CD, face detection, Facebook. These are the some use cases. Now I will tell you some use cases in detail. Classification in action is not easy. Guys, you can see the snapshot of spam folder where this one, so that is scope, guys, and this one from entire spam folder are not a spam. So the machine can understand that which are the mails are spam depending on the features what you have provided, or it can also detect which are not a spam, right? So that is the good thing. So that means machine learning helps to detect spam email and not a spam email. This is a name entity recognition. Guys, you can see the snapshot. This is a one classifier, and you have to give the what should be the output format, the how you can identify the name, right? So it should be highlighted, and preserve spacing, yes. So now you have to give the input. Guys, you can see input is given from the picture, and also you can see the output all the outputs are highlighted, basically the names, and after that they try to predict the potential tags. That means, let's say over here Long Island, right? The Long Island basically the locations. Guys, you can see the color, match the color. Okay, so this is the location. Okay, so then we have the mic. So this is basically the person. Guys, you can see this is the person. So by this way you can understand the names. Okay, so the machine learning helps to recognize names from a text. So now to detect similar or dissimilar images, guys, you can see this is a picture of Taj Mahal. So, and there are a lot of similar pictures. So the machine learning can detect which one is similar picture or the original one, or which is not an original one from this one. The recommendation already I told you. So just see this one. As you can see the picture right from my presentation. Here you looked at this book. You might also consider this one, but the system will recommend you to this one, today's recommendation for you. So that means depending on your previous history, system can predict you or recommend you, not a predict, will recommend you the which one is appropriate for you. Some popular framework or tools, guys, you can see Open NLP, then you have Gate, you have Carrot 2, right? Guys, these are the some popular framework.
These are the sub advanced topics.
Guys, you can go through for your further study. Now I'll tell you what is AI enabled IoT architecture. Guys, you can see the different layers. The first layer is the basically the edge layer, where we have the different devices like Raspberry Pi, Node MCU, drone, we have sensors and all other things. Here we can also apply different machine learning algorithm to check the anomalies, right, or any missing data, etc., etc. After that we have the fog layer. Here you can apply different machine learning algorithm to detect denial of service attack or DDoS attack, or is there any anomalies and all these things, right? So last one is the cloud. So here we actually implement different analytics for visualizations. So here you can also apply different machine learning algorithm for predictions or a different kind of analytics. After that we have the app, that is Android app, right, in your mobile phone. Okay, so here you can use different kind of analytics, and let's say some predictions, what should be your activity, right? So that can be also visualized in this particular app. Okay, so guys, I'll tell you how you can use machine learning algorithm in different IoT application. Let's say human activity detection. So guys, you can see this is the standard approach. That means you have to write a computer program in Python or Java, whatever, and guys, you can see there is a if then else, right? Depending on some certain value, we try to predict whether you are sitting, whether you are standing, and like this. Okay, and this is the standard formula to use. That means if you are using the conventional approach, like write a conventional program like in Java or C or C++, whatever, and try to guess whether you are sitting, whether you are standing, whether you are walking. So that is the conditions. Let's you have to write if else conditions and give the different threshold values, and then you predict all these things based on some standard formulas. But if you use the machine learning approach to do this one, so guys, you can see here is the model, the machine learning model. You have to give input and the model will give some output. Okay, whether you are standing or you are sitting or whether you are walking. So what is the approach? So you have to give different sensor data and the activity into machine learning algorithms, right, and make it a model, and then this model will help you to guess or predict whether you are sitting, whether you are standing, or whether you are walking. So that is the main idea, how to apply machine learning algorithm, because this is the place where you can apply machine learning algorithm. Now I will tell you another AI enabled IoT system, that is fire alert system. You can see from the presentation there are many sensors like light sensor, gas sensor, temperature sensor, humidity sensor and smoke sensor. Raspberry Pi will receive data from sensor and process it and then send it to Amazon cloud where database is present. And now from this database the sensor data will go to Amazon EC2 instance by using REST API. What is EC2 instance? EC2 stands for Elastic Compute Cloud. EC2, CC, that's why it is Elastic Compute Cloud instance. Here actual processing is going on. That means you can use machine learning over here, and EC2 uses just logic determination, right, and send the sensor data to the mobile phone where you have AWS SDK for Android, that means in Android app by using REST API. Your mobile phone will send a request for data and receive the response from the EC2 instance through AWS SDK for Android. And EC2 instance also send an alert to fire brigade if fire occurs, by which fire brigade can take immediate action. Your mobile phone, it means where you have the Android app that controls the Raspberry Pi as well as the sensor through this app. Now I will tell you where you execute your machine learning algorithm and make a model. So this is the platform, that is Google Colab, where you can implement your machine learning code. You can execute also in Raspberry Pi. I will show you later. What is Google Colab? Google is quite aggressive in AI research, provided framework called TensorFlow, that is open source, provided free Jupyter notebook environment called Collaborative or Colab, allows you to write and execute Python in your browser. Zero configuration required, free access to GPUs, easy sharing, supports many popular machine learning libraries. But I will tell you, you can also use R language in Google Colab, but you have to add some add-ons. This is the workflow of Google Colab, guys. You can see this is your computer and this is the backup drive, and you have to sync it, and then you have your drive, and this is the Google Colab notebook VM, that is the virtual machines where you can write your program and execute your program. So why should you use Colab? As a programmer, you can perform the following using Google Colab. write and execute code in Python. So already I told you can also run and execute R, but you have to add something in Google Colab add-ons. Document your code that supports mathematical equations. Create or upload or share notebooks. Very easy over here. Import, save notebooks from or to Google Drive. Import or publish notebook from GitHub. Import external data sets, for example from Kaggle, that is why it is very flexible. Integrate PyTorch, TensorFlow, Keras, OpenCV, etc. etc. Free cloud service with free GPUs. These are the things actually Colab are offering you for implementing any machine learning algorithm in Google Colab or to make a model. So now I will tell you technological challenges. First one is the scalability. So when the network is large, then it is difficult to implement all these algorithms or use AI in IoT. Technological standardizations, because there is no standardization is available still now for AI-enabled architecture. So that's why it is difficult to implement and experiment on that particular area. Wireless challenges. So that is another issue, because we are using the third-party gateway or to implement the wireless communication in the IoT network. Sometimes it is difficult. Power supply. Most of the IoT devices are power backup. So that's why implementing high computational algorithm in IoT network or IoT devices is difficult. Interaction and short range communication, that is also another challenge. Data volumes. IoT generates lots of data. So and that's why it is sometimes difficult to store and process it and interpret it also. Software complexity. So if we have to use complex software, that is sometimes
Very challenging.
because to train the people or use it properly. Thank you.